Jai Hind to all. I am Updesh Kumar Jaiswal, working as an assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. Today, I am going to deliver a lecture on topic message authentication using digital signature and hash function. It is related to subject data encryption and compression. Subject code is HTCS 501. So, firstly, I am going to start from the very basic, that is the definition of message authentication. It is the process of verifying the integrity and authenticity of a message to ensure that it has not been altered during transmission from sender to receiver. Message authentication is a security process that ensures a message origin and integrity during the transmission from sender to receiver side. Message authentication is crucial for protecting data against unauthorized access and tampering in communication system, especially over insecure network like internet, that is the World Wide Web. So, what are the advantages of message authentication? It provides security, trust and legal, protects data against tampering, ensuring both message integrity and origin, establishes a level of trust between communicated party by verifying the sender, provides non-repudiation, which is often a legal requirement in area like digital transaction and contract signing. There are some practical application of message authentication: e-commerce and online banking, in email security, data storage and transfer, secure web communication. So, message authentication ensure secure communication between users and services provided and safeguarding against identity theft and fraud. Digital signature and message authentication are commonly used to prevent email spoofing and phishing attacks. Message authentication protects data from unauthorized access and tampering during storage or while being transferred across the networks. And it also provides the secure web communication using the TLS. There are some important techniques used for message authentication. Basically, digital signature and hash function provide the message authentication. Message authentication is a fundamental and a crucial process to secure digital communication. By using cryptographic methods to protect against tampering and unauthorized access, message authentication helps in ensuring that only trusted message reach their intended destination. So, firstly, I am going to explain about the digital signature, which is used for the message authentication. After that, I will discuss the hash function. So, a digital signature is a cryptographic method used to verify the authenticity and integrity of digital message or documents. Digital signature, in short DS, uses asymmetric encryption. There are two types of encryption, symmetric and asymmetric. But digital signature uses the concept of asymmetric encryption. So, there will be two key pairs, that is the public and private. Key concept of digital signature: authentication, data integrity and non-repudiation. So, authentication, it verifies the sender identity. Data integrity, ensure the message was not altered while transmission. Non-repudiation, preserve the sender from denying the signature. So, sender cannot deny. Application of digital signature. There are many applications of digital signature, but I have discussed here only 10. First, secure communication. So, digital signature provides secure communication, software security and distribution among different users, financial transaction like banking transaction, online shopping transaction, legal and government documents. If you are applying for a tender in a government agency, government forms, so legal documents of the courts. So these are the digitally signed by the sender. Blockchain and cryptocurrency. In cryptocurrency, digital signature concept is very important. Secure authentication and access control. Intellectual property rights protection. So in case of patent filing, in cases of copyright, and there are many intellectual property rights where digital signatures are required. Electronic voting, it is promoted by the different governments. So in case of e-voting, digital signature is also important. Email authentication, healthcare and medical sector, digital signature are required. So we should understand what is the working of digital signature. Digital signature has two main processes. First process is signing, second process is verifying. Signing means creating a unique digital signature on an original message using the sender's private key. And verifying, confirming the authenticity of the signature using the sender's public key. Here public key is used. So private and public key, two types of keys are used in case of digital signature. The whole signing and verifying process is represented here by using this diagram. Firstly, the original data is hashed by using the hash function. Here I have taken example of hash is 10110011011011. So after that, encrypts hash function using signer's private key. Here private key is used of the sender side. So we will get the signature, and certificate authority provide certification, and using the certificate and signature both are attached. Then data is signed digitally at the sender side, then it's sent to the receiver side. At the receiver, verification process is performed. So the received data signed digitally document is now divided into two parts, that is the data and signature, and data is decrypted using the signer's public key, and hash function is again applied here, signature, then hash function is used, and using the hash, if the hashes, earlier hashes and after hashes both are match, then the signature is valid. So here the hash, both the hash are similar. So this diagram is theoretically explained by me. Signing process has two steps: message hashing and the encrypting the hash. In case of message hashing, the sender applies a hash function to the original message for creating a hash value, that is called as the digest. And the second is the encrypting the hash. The sender encrypt the hash, that is the digest, with their private key, creating the digital signature. The message and digital signature both are sent to the receiver side. At the receiver, verifying process performed, and it has mainly three steps: hashing the received message, decrypting the signature, and comparing the hashes. So in first step, the recipient hashes the received message. In the second step, the recipient uses the sender's public key to decrypt the signature and revealing the original hash. If the hashes match, the message is authenticated. If not, it have been tampered, altered. This process can be represented by some another diagram. Root certificate authority, register company certificate authority. Then alias is a authorized user, means sender. Document is digitally signed by the alias. And at the receiver side, Bob, who is the recipient. The recipient verifies the document, it is valid or invalid. The verifier compares the original document to the digital signature, and certificate authorities certificate to ensure the integrity and authenticity of the document. So this is the working of digital signature. In the simple diagram, suppose this is the original message, I will pay $500. Alice, who is the sender, sign and encrypt the message. This is the alias private key, and now message is encrypted using the key and hash function. At the receiver side, Bob verify and decrypt the received message. This is the received message, and applying the Alice public key. Alice has two type key, private key and public key, and using the public key, the original message will get, I will pay $500. This is the simple diagram how the digital signature works. So what are the benefits from digital signature? There are lots of benefits. Authentication of sender's identity, data integrity, non-repudiation, enhanced security, increased efficiency and speed, cost saving, environmental benefits, global acceptance and legal validity, convenience and flexibility, improved customer experience and certificate. So these are the main benefits of the digital signature. Now, after the digital signature, hash functions are also used for the message authentication purpose. I have already told. Hash functions are mathematical algorithms that transform input data of any size into a fixed size string of characters. Typically, string of character is a sequence of number or letters. The output, known as hash value or digest or checksum, is unique to each input, making hash function invaluable in various digital security and data integrity applications. For message authentication, the hash of the message is calculated and sent along with the message. However, hash function alone are not sufficient for message authentication since they do not use keys. There is no concept of keys, so making them vulnerable to tampering. In practice, hash functions are combined with a secret key generally, simply. So some common example of hash function for message authentication: SHA-256. SHA stands for Secure Hash Algorithm using the 256 bit, a widely used secure hash function for message authentication in cryptographic protocols. Next one is the SHA-3, Secure Hash Algorithm 3, a newer highly secure hash function used in digital signature and encryption techniques. Then HMAC SHA-256, that is the hash based message authentication code with SHA-256, a combination of SHA-256 and a secret key for secure message authentication. Then HMAC SHA-512, hash based message authentication code with SHA-512. It is similar to HMAC SHA-256 but offers strong security with a larger hash size. Since the size is larger, so it provides more security as compared to HMAC SHA-256. Then most popular MD5, that is called as the Message Digest Algorithm 5, has function still used in some application but considered insecure sometimes. Black box cryptography hacks function, a fast and secure alternative to SHA-2, optimized for software efficiency. RIPEMD 160 race integrity primitive evolution message digest using the 160-bit cryptography hacks function used as an alternative to SHA-1. So SHA-1 and SHA-2 both are obsolete, and in place of these SHA-3 and SHA-256 RIPEMD and BLACK2 are used. So it is important to understand what is the working principle behind the hash function while providing the message authentication. A hash function takes an input message and converts it into a fixed length hash value, that is called as the digest checksum. It ensures integrity by producing a unique hash. Even a small change in the input drastically alters the output, that is called as the avalanche effect. For message authentication, a hash based authentication code, that is called as the HMAC, combines a hash function with a secret key. The receiver verifies the hash by recomputing it using the same function and key, ensuring the message authenticity. Cryptography hacks function like SHA-256, I have already discussed about this, HMC, SHA-512 and BLACK2 are commonly used for secure message authentication. I have already discussed about these things. So this is the whole working principle of hacks function. It is mainly divided into the 5 steps. So it is very important to understand what are the benefits from the hash function. First benefit is the data integrity. So data is in the pure form, no alteration is performed from the sender to receiver side, so data is original. So we can say data integrity is provided by the hash function. Efficiency, it is more efficient as compared to other cryptographic techniques. Secure, because no public and private key are used, so this is more secure as compared to other techniques. Compact representation and non-repudiation, so sender cannot deny if some mistakes occur. So these are the different references. I have used 3 research paper and 1 website for making this lecture. Thank you and Jai Hind to all.